So, again, methods for solving quadratics. We're going to look at that as we go through our Unit 9 Part 2 Retake review. A couple things to remember is that you can solve using difference of squares, and this is factoring in the case when you have perfect squares in your first term and your last term. The bx term is 0, and of course you're subtracting both the first from the second, or the second from the first term. The other thing here, we're going to scratch out this 3 terms AC. The other thing we're going to have here is using the quadratic formula to solve. And again, with the quadratic formula, it always works. Completing the square, that's one of the more tougher methods of solving, so typically we won't use that often. And you can also use square roots, and remember, when you take the square root of a side, it becomes plus or minus. That's important. Alright, what is the discriminant? Well, the discriminant is the part of the quadratic formula and it is the b squared minus 4ac component from the quadratic formula. This is also what goes under the radical. And what does it tell us? Well, it tells us a couple things, but one of the most important things it tells us is the number of real solutions, or the number of solutions in general. If b squared minus 4ac is greater than 0, you have 2 real solutions. If b squared minus 4ac is equal to 0, you have 1 real solution, and it's going to be your vertex. And if b squared minus 4ac is less than 0, you have no real solutions. And in fact, what you really have is a couple of imaginary solutions, but we're not going to talk about that in this class. So let's go ahead and take a look at our first example here. In this example, we're going to notice a couple things right off the bat. We notice that the bx term is equal to 0. We notice that we're subtracting, and that's really important to remember, that there's subtraction there. That is called a difference. And we're also going to look at x squared is a perfect square. We're going to look at 144. That is also a perfect square. So with that in mind, we're going to use a difference of squares. To solve this. So what we're going to do is we're going to start off with taking the square root of x squared, which is equal to x. We're going to take the square root of 144, which is equal to 12. And then we're going to write our 2 factors. Our factors will be x in both factors, 12 will be in both factors, and we're going to add and subtract that 12. Of course, we're setting it equal to 0 to solve for x. What we know is that when we set both factors equal to 0, we get x plus 12 is equal to 0, x minus 12 is equal to 0. What we're then going to get is x is equal to negative 12, and x is equal to positive 12. So we can say that x is equal to plus or minus 12, and that would be our solution. Another alternate way to solve this is by using square roots. In this case, we'd take x squared minus 144 is equal to 0. That should be 144. We're going to add 144 to both sides of the equation. So I'm going to designate that over here. And we'll get x squared is equal to 144. Take the square root of both sides, and you get x is equal to plus or minus 12. Both of those are a very valid way for solving the problem. Looking at this problem here, we have x squared minus 12x plus 32. And we're going to attempt to factor it first. That's what we're going to attempt to do, is factor it first. Our a value here is 1. In case we're forgetting that, that is our coefficient there. Our b is equal to negative 12. Our c is equal to 32. And our ac value here is equal to 32 as well. This tells us we need to find something that multiplies to 32 and adds to negative 12. If we have a positive here, a positive 32, and our product's positive and our sum is negative, that tells us that the only way we can do that is if one of our factors is negative. But if our product is positive, both of our factors need to be negative. So this makes things easy. Negative 1 and negative 32, that gives us a sum of negative 33, which is not going to work. Negative 2 and negative 16, they multiply to 32, but they add to negative 18. That's not going to work. Negative 3 does not go into it. Negative 4, though, multiplied by negative 8 would give us positive 32, and they would sum to negative 12. These are going to be our factors. Now, since a is equal to 1, negative 4 and negative 8 become part of our factors. And it is only because a is equal to 1. I can then write my factors as x minus 8 times x minus 4. You can Punnett square these out, and they'll work out perfectly. Again, x times x is going to give you x squared, and you won't be modifying the minus 8 and the minus 4 in the Punnett square. So, now that we have x minus 8 times x minus 4 is equal to 0, we can set both factors equal to 0, so x minus 8 is equal to 0, x minus 4 is equal to 0, and from there I'm going to add 8 to both sides. When I do that, I get x is equal to positive 8. I can add 4 to both sides, and I get x is equal to 4. I could go back and check my answers. I could also put this in the calculator. And I would see that if I put 8 in for x, I'm going to end up at 0. If I put 4 in for x, I will end up at 0. In our next example here, we have 2x squared minus 9x minus 5. We're also going to attempt to factor. And it's important to note that my leading coefficient is 2, so I can't use my shortcut method. But a is still going to be equal to 2 here, b is equal to negative 9, and c is equal to negative 5. Therefore, ac is going to be equal to negative 10. Which means I need to find something that multiplies to negative 10 and adds to negative 9. Well, there's not many factors of 10. We see our sum is negative 9, so it's probably going to involve 10 and 1. And that would be negative 10 multiplied by 1 would give us negative 10, and negative 10 plus 1 is equal to negative 9. Now, since a is not equal to 1, we have to factor by grouping. So factor by grouping is going to be our method, which means we're going to rewrite the equation 2x squared minus 9x minus 5 equal to 0. We're going to rewrite it using our negative 10 and our 1. I'm going to set it up here with 2x squared plus 1x minus 10x is equal, or minus 5 is equal to 0. I could set this up any number of ways. I could have set it up also as 2x squared minus 10x plus 1x minus 5 is equal to 0. But I chose this way. As we factor by grouping, I'm going to look at my first two terms only. My GCF between 2x squared and x is going to be x. This means I'm going to divide both terms by x. I also put x outside of my parentheses. 2x squared divided by x is going to be 2x. and 1x divided by x is just 1. If I look at my equation, x times 2x gives me 2x squared, x times 1 gives me x, so x times 2x plus 1 is indeed the same as 2x squared plus 1x. Now we're going to factor this second group here. Looking at negative 10x and negative 5, both of these have a GCF of negative 5, which means I'm going to divide a negative 5 out from both terms. I'm also going to put that outside the parentheses. Negative 10x divided by negative 5 is 2x, and negative 5 divided by negative 5 is 1. I'm happy right now because what I notice is that both of these parentheses match. This is important in factor by grouping. They are also now a GCF. So I will divide them out from both sides here. When I divide them out from both terms, I put them outside the parentheses. Since it's the entirety of 2x plus 1, I put that in parentheses. Those will cancel out here, and I will be left with x minus 5. And 2x plus 1 times x minus 5 is equal to 0. You could go ahead and put that in a Punnett square, and you would get 2x squared minus 9x minus 5. Now that we've reached this point, we now need to go and solve for x. I'm going to take 2x plus 1 and set it equal to 0. I'm going to take x minus 5. Oops. Need to erase that, not cover over it. So we're just going to hit the back button here a little bit to undo some work. And again, that does not seem to be working, so we are going to just do this. And I'm going to set x minus 5 is equal to 0. Both of my factors are set to 0. I'm going to subtract 1 from both sides. That'll give me 2x is equal to negative 1. Divide both sides by 2, and x is equal to negative 1/2. Add 5 to both sides here. X is equal to 5. So my answers would be x equals 5 and x equals negative 1/2. These are pretty easy to factor. I also could have used a quadratic formula to solve this equation. Alright, looking at this example, 2 times x plus 1 quantity squared is equal to 18. The key to this problem is going to be that I see that I have a squared factor on one side of the equation. If I gave you a problem that was 2x equals 18, you would know to divide by 2 to start off with, and you'd have x is equal to 9. Our goal is to get x by itself and solve for x. So our first step here would be dividing by 2 on both sides, much like we did over here. We're going to do with our new problem. That will give us x plus 1 quantity squared equals 9. Now I have a squared item on the left side and a perfect square on the right side, by the way, but that's inconsequential. What's really important is I have x plus 1 quantity squared, and I am going to choose the method of square roots to solve for x. If I take the square root of both sides of the equation now, I am going to be left with, on my left side, just x plus 1. Taking the square root of a squared quantity gives you that quantity itself. Of course, the square root of 9 is equal to 3, but it's plus or minus 3 because I took the square root of it. Because negative 3 times negative 3 could also be 9, just as much as 3 times 3 could also be equal to 9. At this point, I'm going to rewrite the equation to represent x plus 1 is equal to 3. And x plus 1 can also be equal to negative 3. This plus or minus sign here gives rise to the two solution problem. At this point, I'm going to take the same steps to solve for x in both cases. It's still subtracting 1 from both sides. I will end up as x is equal to 2, or I will end up as x is equal to negative 4. If I were to go through and plug those into my original equations, I would get 2 plus 1 is 3, 3 squared is 9, 9 times 2 is 18. If I plug in negative 4 for x, I get negative 4 plus 1 is negative 3. Negative 3 squared is 9. 9 times 2 is also 18. All right, looking at our next example, x squared plus 10x is equal to 30. Here is a big goal. This is not equal to 0. Which means I can either do a number of things. One, I could set equal to 0. Or two, I could try to complete the square. I think for this problem, one of the things we're going to do is we're going to attempt to complete the square. Trying to think about 30 here, we would ultimately need to get to x squared plus 10x minus 30 is equal to 0 if we were to set equal to 0. And I'm going to write that down there. X squared plus 10x minus 30 is equal to 0. We would need something that would multiply to negative 30 but add to 10. My only factors I can think of for 30 are 1 and 30, which are not going to add to 10, 2 and 15, that's going to be a 17 or a 13, 3 and 10, well, I think we just mentioned 3 and 10, 2 and 15, again, that's 17 or 13, 3 and 10 is going to be 7 or 13, and 5 and 6, well, they could add to 11 or add to 1 depending on which ones were negative. So at this point, completing the square might be our best option. Now to complete the square here, we have x squared plus 10x plus some mythical quantity here, or unknown quantity I should say, that will make x squared plus 10x plus something a perfect square. Whatever that unknown quantity is, we're going to add to both sides of the equation. Now to do this, we're going to divide our 10x by 2, or our 10 by 2, and what that's going to give us is x plus 5. Or the 10, that should give us, 5 here. Which means we're going to have x plus 5 quantity squared. We are then going to take our 5 squared, and we are going to add it to both sides of the equation. Well, 5 squared is 25. So we're adding 25 to both sides of the equation. Of course, x plus 5 quantity squared is going to be x squared plus 10x plus 25. So that's what we have on the left side. Now here we have x plus 5 quantity squared is equal to, on the right side, 55. Okay? So again, what we did here is we took the 10x, we divided by 2, that gave us our 5, and we made it x plus 5 quantity squared. We then took 5, we squared it to get to 25. So now I have x plus 5 quantity squared is equal to 55. I can now take the square root of both sides of the equation. This will leave me with x plus 5 on one side of the equation, and it will leave me with plus or minus the square root of 55 on the other side of the equation. We still haven't solved for x. We need to get rid of this plus 5 on the left-hand side. So we are going to do that by subtracting 5 from both sides of the equation. On the left side, we'll end up with x. On the right side, I know negative 5 and radical 55, I cannot simply combine them together. It's not 55, it is the square root of 55. And since the square root of 55 is not a perfect square, I'm going to leave it under the radical sign. This means my answer will end up as x is equal to negative 5 plus or minus the square root of 55. That gives us two solutions, as we would anticipate from most quadratics. 55, the factors of 55, just so we know, 55 involves 1 and 55 and 5 and 11. None of those are perfect squares, so I cannot reduce this any further or simplify it. Therefore, x is equal to negative 5 plus or minus the square root of 55. All right, in this latest example, the thing that should stand out to us is that we have z cubed. We haven't really done a lot with z cubed. So when we look at it, we say, oh, hey, we've got a z in this term here as well, and a z in this term. So when we think about GCFs, and we should always be thinking about GCFs, we see z should be part of our GCF. But there's something else that's interesting here. We have a 7, a 28, and a 28. 7 can go into 7, 28, and 28 as well. So we're going to factor out our 7z first. When I do that, that's basically 7z cubed plus 28z squared plus 28z. Each term here is going to be divided by 7z. And what we're going to end up with is z squared plus 4z plus 4. And of course that's going to be multiplied by our 7z. We can't forget the 7z. That is part of our solution here. And of course this is all equal to 0. Now this part, z squared plus 4z plus 4, we can factor by grouping. And what we notice again here is our coefficient is 1. So for this now, we're going to have our a value is 1, our b value is 4, c is equal to 4, ac is equal to 4. So we need to find something that multiplies to 4 and adds to 4. Well, that's pretty obvious, 2 times 2 and 2 plus 2. Since a is equal to 1, I can use the 2 and the 2 as my factors, which means I'm still going to have my 7z. That didn't go anywhere. And 7z is going to be multiplied by z squared plus 4z plus 4, or its factored form. That is going to be z plus 4. Oops, sorry about that. That's not actually correct. That's going to be z plus 2 times z plus 2. And that's equal to 0. I see that I have z plus 2 and z plus 2, so that's a z plus 2 quantity squared. And of course, I have not lost my 7z out front. Both those are equal to 0, so I can set 7z equal to 0. If I divide by 7 on both sides, z is equal to 0 is one of my solutions to this problem. The other case, I'm going to set z plus 2 equal to 0. Subtract 2 from both sides, and I will end up with x equals negative 2. So I will find two solutions, even though I have z cubed. And again, I write that pesky x in there instead of z. But in this case, I have z is equal to 0 and z is equal to negative 2. It's actually two solutions at z equals negative 2, though it won't necessarily look like that graphically. So we have the solutions of z equals 0 and z equals negative 2. All right, looking at our next example, 2x squared minus 24 is equal to negative 8x. Again, in order to use any of these solving methods, we have to have our equation equal to 0. How are we going to do that? Well, if we add 8x to both sides of the equation, we can get our equation equal to 0, our function equal to 0. The 8x, of course, cannot be combined with 2x squared. They don't have the same exponent. We cannot combine the negative 24 and the 8x because they both don't share the same variable, x. So we will end up with 2x squared plus 8x minus 24, and that's equal to 0. Here to solve this problem, I'm going to take a look at it, and I notice that I have a GCF of 2. I'm going to factor it out. So I'm going to get 2 times x squared plus 4x minus 12 is equal to 0. I'm not going to complete this example, but I will tell you this is a great place where you can solve this by factor, by grouping. All right, Ms. Sotelo's wall tapestry has a dimension of x plus 3 and x plus 4 feet. The area of the tapestry is 132 square feet. We need to find the length and width of the tapestry. Well, first things we need to remember is that area is equal to our length times our width. We can arbitrarily assign our length as x plus 3 and our width as x plus 4. Therefore, area is equal to x plus 3 times x plus 4. We also know that our area is also 132. So we can say that 132 is equal to x plus 3 times x plus 4. Now, in order to solve for x, I'm going to have to multiply x plus 3 and x plus 4, which I'll do over here in a nice, convenient Punnett square. Sorry, multiplication array. X and 3, x and 4. Make sure I put the plus signs there so we know it's positive. X times x gives us x squared. X times 3 gives us 3x. 4 times x gives us 4x. And 4 times 3 is 12. So now we have 132 is equal to x squared plus 7x plus 12. You'll notice the b term there, because our leading coefficient is 1, you notice the b term is just the sum of 3 and 4, and our c term is just the product of 3 and 4. Okay. Now, to solve this problem for x, this needs to be equal to 0, which means I'm going to subtract 132 from both sides of the equation. When I do that, I'm going to have 132 minus 132 is 0. And I will be left with x squared plus 7x minus 120. Now, some of you might know that 15 times 8 would give you 120, and the difference between 15 and 8 is 7. And since it's a negative product and a positive sum, that your factors would be 15 and positive 15 and negative 8. However, that could be a little tough, so we're going to use the quadratic formula here to solve. And we haven't done that yet, so our a value is equal to 1, our b value is equal to 7, and our c value is equal to negative 121, or negative 120. First thing we're going to do is we're going to take our discriminant, b squared minus 4ac, and we're going to solve for that. Of course, we have b is 7, so we're going to square 7 minus 4 times 1 times negative 120, and you'll notice I put those all in parentheses. Entering that into your calculator, you get a value of 529. Now, we know that b squared minus 4ac is going to be what we have as our square root, so we're going to plug this into the larger part of the quadratic formula, which is x is equal to negative b plus or minus the square root of our discriminant, so in this case 529, all over 2 times a. Well, we already know what our b and a, so x is equal to negative b, it's negative 7, plus or minus the square root of 529 over 2 times 1. Okay. Now, here's what we need to do. 529, we need to take the square root of it. What we need to do, regardless of whether it's a perfect square or not, is attempt to take the square root of it. When we do that, we find out 529 is a perfect square of 23. So x here is going to be x is equal to negative 7 plus or minus 23 over 2. That gives us two potential solutions, which is negative 7 plus 23 over 2 and negative 7 minus 23 over 2. That would leave us with, if we put this in our calculators, 8, and if we put the bottom one in our calculators, negative 15. Okay? All right, which is kind of what I told you we should expect at the very beginning. Now, we still haven't found the length and width here. That's the challenge. We were asked to find the length and the width. We've just found the values of x. So here's what I would do. Negative 15 probably isn't going to work, because negative 15 plus 3 is going to be negative 12. Negative 15 plus 4 is negative 11. You can't have negative lengths or widths. So we're going to use our 8 here, and we're going to plug it into our original values. So I'm going to have 8 plus 3 is equal to 11. And 8 plus 4 is equal to 12. And our length is 11, our width is 12. And if we take 11 times 12, we get 132. All right, we're going to use another example here to solve using the quadratic formula. Again, if we need to remember, our quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And the quadratic formula always works. Okay, but when we look at this example problem, right off the bat, we see it's 7x. That's not 0. So we have to set our equation equal to 0 by subtracting 7x from both sides of the equation. When we do that, we get 2x squared minus 7x minus 4 is equal to 0. Our a value is 2, our b value is equal to negative 7, and our c value is negative 4. We're first going to solve for our discriminant. Our discriminant is b squared minus 4ac, and in this case it's going to be equal to, and notice I'm putting the negative 7 in parentheses and then squaring it, minus 4 times our a value of 1 times our c value of negative 4. That value, when we plug it into our calculator, is 81, which is a perfect square, which makes us happy. If you came up with negative 17, you didn't put parentheses around the negative 7, and you squared on your calculator negative 7 squared. That will tell the calculator to take 7, square it, and then take the negative 1, giving you your negative 17. The correct answer is 81. So now we're going to put that in our quadratic formula. X is equal to negative, and here's another area that people make mistakes, put the negative 7 again in parentheses, because ultimately what you're going to get is negative 7. So negative of negative 7 plus or minus the square root of 81 over 2 times 2. When we do that, a negative and a negative give us a positive. So we'll have positive 7 plus or minus the square root of 81, which is also known as 9, all over 4. That will give us two possible solutions coming from the plus or minus sign, which means we'll have 7. That will give us 7 plus 9 over 4. And it'll also give us 7 minus 9 all over 4. Plugging these values into a calculator, we end up with 7 plus 9 over 4 is actually equal to 4, and 7 minus 9 over 4 is equal to negative 1/2. And those would be our answers to both problems. All right, let's remember what a discriminant is, because we're asked for a quadratic function that results in a discriminant of negative 9. That's the b squared minus 4ac component. But it's also the part that we're taking a square root of. We know we can't take the square root of negative numbers. There's no two identical numbers that multiply to negative 11. So, how many solutions does the function have? Well, when b squared minus 4ac is less than 0, we know that there are 0 solutions. But also something to think about is, what is a solution? A solution is also known as an x-intercept. If we don't have any solutions, we have no x-intercepts. So therefore, without any x-intercepts, you cannot cross the x-axis. So no, the function will not cross the x-axis. And finally, is it possible for the function to cross the y-axis? Yes. Our domain is from negative infinity to positive infinity, which includes x equals 0, which is where we have our y-intercept. All right. Finally, we have the function h of t is equal to negative 16t squared plus h naught gives the height of an egg dropped from the height of h naught after t seconds. The egg is dropped from a height of 14 feet. So what does h naught and h of t stand for? Well, h naught stands for our height at t equals 0. It's also known as our initial height. another way, this is where the egg is dropped from. H of t represents the height at any time t. Okay? So whatever the height is, if I want to find out the height at 1 second, that would be h of 1, and that would be the height of the egg at 1 second. So we need to create an equation that models the egg being dropped from 14 feet. Well, 14 feet is your initial value. That means it's equal to h naught. And so we're just going to rewrite our equation as h of t is equal to negative 16t squared. That's the component due to gravity. Plus h naught here, which is 14 feet. Finally, we're asked how long does it take the egg to hit the floor? Round to the nearest hundredth. Well, when the egg hits the floor, our height, h of t, is equal to 0. So I'm going to substitute in 0, so I have my equation, h of t is equal to negative 16t squared plus 14. And I'm going to substitute 0 in for h of t. So 0 will be equal to negative 16t squared plus 14. To solve this problem now, I'm going to use the method of square roots to solve it. I'm going to subtract 14 from both sides, and I get negative 14 is equal to negative 16t squared. I can divide both sides by negative 16. When I do that, I'm going to get negative 14, and let me make that clear that that is negative 16, not negative 76. I get negative 14, or shoot, actually, I'm not going to get negative 14. When I look at negative 14 over negative 16, I'm going to get 14 over 16 is equal to t squared. I can reduce this. Both have a 2 in common, so I could reduce this to 7/8 is equal to t squared. I'm going to take the square root of both sides of the equation, and I'm going to end up with t is equal to plus or minus the square root of 7/8. Now, I know that we're looking for time. Time has to be greater than 0, greater than or equal to 0. So I now know my time is equal to the square root of 7/8. I can rewrite that as a square root of 7/8 over the square root of 8. But I really don't need to. We're looking at time here, so I want to get a decimal answer. Round to the nearest hundredths is 2 decimal places, so I'm going to put that into my calculator. So when I put this into the calculator, I'm going to take second x squared. That would give me the square root. I'm going to hit alpha y equals enter for my fraction. Type in 7/8, and I'm going to get that t is equal to 0.935 seconds. Rounding to 2 decimal places, t is going to be 0.94 seconds. All right, average rate of change. What is the average rate of change of a function on the interval for f of x equals 3x squared minus x on the interval -2 to +2? Average rate of change is slope, which means I have m is equal to y2 minus y1 over x2 minus x1. I have an x1 and -2. I have an x2 and 2. So I'm going to have 2 ordered pairs of -2, comma something, and 2, comma something. How am I going to find out what those unknown values for y2 and y1 are? Because that's what these are. Well, I'm going to go into my calculator. In y1, I'm going to type 3x squared minus x, and then I'm going to go to second graph to get to my table. As I do that, I'm going to go to x equals -2. When x is equal to -2, my y value is 14. When x is equal to positive 2, my y value is 10. Therefore, my m value here, m is equal to 14 minus 10. Those are my y values, y2 and y1. And I'm going to have negative 2 minus positive 2 here. You'll notice again that negative 2 and 14 are an ordered pair, and 2 and 10 are also an ordered pair. When I get done with my math here, 14 minus 10 is 4. Negative 2 minus 2 is going to be negative 4. My slope is negative 1, and that is my rate of change. For the final part here, graph the system and find the solutions. We have y is equal to x minus 1 quantity squared minus 2. That's a parabola. And we have y is equal to x minus 1. Well, let's graph this guy first. It's the easiest one to graph. We have an x-intercept at 0, negative 1, and a slope of 1. So I'm going to start there. And I'm just going to go up 1 and over 1. And hopefully draw a pretty straight line on that. Close. The other thing I'm now going to do is graph y equals x minus 1 quantity squared minus 2. I know that that's a parabola, and it has a vertex at 1, negative 2. So I'm going to find that point, 1, negative 2. I see that my vertex is below the graph of x minus 1. I'm going to go up and open upward, so I'm going to have two solutions. Okay. I'm going to go to my calculator now, and I'm going to enter in x minus 1 quantity squared minus 2. I'm also going to enter in x minus 1. And I'm going to go to the table. The table is not only going to give me the points for the parabola, which I see again has a vertex at 1, negative 2. It goes through the points 0, 1. It goes through the point 2, negative 1. But I also want to do something very interesting. I want to go through and check on my table and see if I can find all my intersection points. I see I have one of my intersection points right now, or one of my solutions, at 0, negative 1. But looking at my table, I'm going to look at where, for the same x value, both the functions have the same y value. I've already found that when x equals 0, y equals negative 1. And as I scroll through this, I see at 3, at x equals 3, both solutions, or both equations, give me y is equal to 2. If I'm going to graph that, I see 1, 2, 3, 1, 2. I see they intersect at that point. At that point, I'm just going to sketch the rest of the graph. I have a system of equations. They intersect twice. Therefore, I have two solutions, 0, negative 1, and 3, 2. And again, when you look at it on the table, when x is equal to 0, both y1 and y2 are negative 1. And when x is equal to 3, y1 and y2 are equal to 2. Alright, that concludes our lesson for today. Please go and start working on the review assignment. These should be a good guide for you. And we will go over the review assignment tomorrow in class on Tuesday, and then you will retest, I should say, on Wednesday. Please take a diligent effort at this, as we will not be doing any more retakes on Unit 9, Part 2, after Wednesday.